All right, let's take a look. So, the Pythagorean Theorem, one of my favorites. Love this. This is actually also known as the law of right triangles. But let's take a look. What is this talking about? It's about right triangles, okay. And it's about side lengths. So you're going to see Pythagorean Theorem questions all year. So good, we're talking about it now. So write this down. The sum of the squares of the legs of a right triangle equals the square of the hypotenuse. So let's take a look. Leg 1, so the sum of the squares of the legs equals the square of the hypotenuse. So first of all, we need to know what the legs of a right triangle are. Leg 1, leg 2. The longest side is the hypotenuse. And how do you identify that? Well, I always think about this box as being an arrow, and it's pointing to the longest side. So there we go. That's the longest side. That's called the hypotenuse. The only triangles that have hypotenuses, I don't know, are right triangles. So it's not necessarily if it were a scalene triangle, if it has the longest side. I mean, if it were an obtuse triangle or something, the longest side is not a hypotenuse. It's only an hypotenuse for right triangles. So these are known as the legs right here. And this is the hypotenuse. So what we're going to do, let's take a look, is we're just going to call this, and I always label them A, B, and C in alphabetical order based on size. So the shortest side is A, the second shortest side is B, and then the hypotenuse is always going to be C. If that's the case, what it's saying is A squared plus B squared equals C squared. We're going to look at some proofs on this, on why this works. But here we go. Let's look at an example. Find the missing side. So A squared plus B squared equals C squared. Well, this is going to be my A, this is my B, and this is my C. Okay, let's just plug everything into the theorem. So this is going to be 5 squared plus B squared equals 10 squared. So 5 squared plus B squared equals 10 squared. 5 squared is 25. B squared is B squared. 10 squared is 100. We then subtract 25 from both sides. So we got to do a little algebra here. You're going to get B squared equals 75. Take the square root of both sides. And B is approximately equal to 8.7. So I don't think there are going to be any problems where you have to simplify the radical here. I know we did that at the beginning of the year. If you did, that would be, 5 radical 3, if you had to simplify that, put it in simplest radical form. But I don't think you're going to have to do that. So 8.7, that's what, by the squiggly equals, means approximately equal to. So it was really 8.66 something, and I rounded it to the nearest tenth. So there you go. That's Pythagorean theorem. Things that come up a lot, though, are these things called Pythagorean triples. And basically all they are just sets of integers that work and create a right triangle. So here's one example, 3, 4, and 5. So I can make this 3, I can make this 4, I can make this 5, and that would work, right? So let's take a look. 3 squared plus 4 squared, does that equal 5 squared? Yeah, it does. 3 squared is 9, 4 squared is 16, that equals 25. Here are some other triples that show up a lot. 5, 12, and 15. 5 squared is 25. 12 squared is 144. 25 plus 144 is, what is that? 100. Oh, that I miswrote here. That's 13 squared. Let me fix that. That's 169. That's why I was a little thrown off. So 5, 12, 13. So yeah, 5 squared is 25 plus 144 is 169. That works. And then the last one is 8 squared plus 15 squared plus equals 17 squared. 64 plus 225 equals 289, which is what 17 squared is. So these are the 3 most common ones. There are an infinite set of Pythagorean triples. So you might want to memorize these, maybe. Definitely 3, 4, 5. Any multiple of 3, 4, 5 works, 6, 8, 10, 9, 12, 15, and so forth. So thank you so much for watching. Let me know if you have any questions.